We will continue the course for Commercial Mechanical Inspector M2, and this part is number 4, part 4, about fuel supply. Recommended study time 180 minutes. Module 4, required reference. The required reference in the International Mechanical Code 2021, Chapter 13, and International Fuel Gas Code 2021, Chapter 13. Fuel supply. Illustration 4a, fuel supply. How fuel supply is governed is important. We want to prevent fires, leakage, and spills involving gas and fuel oil. Study tip. This module we will cover storage, piping system, allowable material, sizing, and installation of gas piping system. We will also go over pressure regulator appliances connection and overpressure protection. Let's jump in.
Understanding how the references work together. IMC Chapter 13 regulates the design and installation of fuel oil storage and piping systems. The International Fire Code, IFC, covers subjects not addressed in detail in IMC Chapter 13. IFGC Chapter 4 covers the sizing, installation, and allowable materials for gas piping systems. IFGC Appendix A is informative and not part of the code, but it provides design guidance, useful facts and data, and multiple examples of how to apply the sizing tables and sizing methodologies of IFGC Chapter 4.
General usage. International Mechanical Code 2021, Chapter 13, Section 1301.3. Appliances must be designed for use with the type of fuel to which it will be connected. Reapproval would be required to convert appliances to a different fuel type. Did you know there are significant differences between liquid fuel burner and assemblies and gas fuel assemblies, impacting the way fuel is to be stored on site, in addition to the code regulations surround each. As we see here, illustration 4b, non-pressurized fuel supply. This is non-pressurized fuel supply. We need tank and pump, fuel oil, kerosene, and gasoline, and stored on site, typically at atmospheric pressure. Because of this, they require pumps to move the fuel into the burner and a nozzle to spray the fuel into air to get a good fuel air mixture and steady combustion. Illustration 4c, pressurized fuel supply. Gas, on the other hand, is the most often pressurized, so the burner assembly will have a valve instead of pump. Understanding the field, the pressurized gas in combustion with the chimney effect can be used to induce air flow for combustion with the natural draft or induced draft combustion. The gas is shot at high velocity through a small hole called the orifice. As we see here, this is a natural gas orifice, and here is propane orifice. Illustration 4d, natural gas versus propane orifice. Liquid propane is naturally delivered at a higher pressure than most natural gas or liquid butane, and therefore requires a smaller orifice. Natural gas orifice are larger than propane orifice. Illustration 4e, fuel oil burner. This is fuel oil burner. Fuel oil requires a pump and nozzle to spray the fuel into the air to burn. Illustration 4F anti-siphon valve. According to the code section 1301.4, if an oil burner is below any part of the oil tank, an anti-siphon valve is required to prevent the oil from flowing from static pressure in the tank siphoning. Fuel piping material, International Mechanical Code 2021, Chapter 13, Section 1302, International Fuel Gas 2021, Chapter 4, Section 403. Piping material for fuel oil piping are listed in Table 1302.3, which we will look at in a minute. Non-metallic pipe in a material listed as specified in ASTM D2996, although not stated in International Mechanical Code. Non-metallic pipe refer to filament wound fiberglass reinforced pipe FRP. Illustration 4G, non-metallic pipe. This is fiberglass reinforced pipe can only be installed outside, buried beneath the surface. Keep in mind that most plastics are degraded by fuel oil and those are not allowed. Fuel oil piping and fittings. Material. Okay, this table shows the material and the standard related to it. Illustration for each. Table 1302.3 fuel oil piping. This table is taken from the International Mechanical Code and lists material used for fuel oil piping and ASTM standard to which each material can conform. Illustration for steel pipe. Steel is the only material that can be used for both fuel oil and natural gas. Copper is not recommended for gas due to potential for corrosion, but if used, it must have low hydrogen sulfide content. Understanding the field. Cast iron, PVC, and CPVC are not allowed for gas and fuel oil. Polyethylene and polyamide plastic pipe are acceptable for natural gas but not for fuel oil. When using threaded material pipe for gas, the International Fuel Gas provides Table 403.8.2 as a specification for the number of threads that should be cut. Specification for threading metallic pipe. The specification for the threaded metallic pipe according to threading only. Illustration 4J, Table 403.8.2 metallic pipe threading. This table gives specification for metallic pipe threads depending upon the diameter of size of pipe. Fuel oil installation. International Mechanical Code 2021, Section 1302.7. Illustration 4K pumps. Oil pumps are referenced Section 1302.7. They must be of positive displacement, which automatically shut off the supply and prevent backflow when the pump is not operated. Joints and connection. It is in International Mechanical Code 2021, Section 1303. This is the threaded pipe, and this is the welded, and this is the union, and this is the flange. Illustration 4L fuel oil joints and connection. Joints between steel pipe or fitting can be threaded, welded, or mechanical joints. Let's look at joints that are not allowed in fuel piping. Study tip. Prohibited joints in fuel oil piping. Unions requiring gaskets or packings, this prohibited. Right or left coupling that are threaded with right threaded on one side and left threaded on the other side is not accepted also. Sweet fitting, employing solder that has a melting point is less than 1000 Fahrenheit, mean 538 Celsius. Note that typical solder used for copper piping melt at temperature below 400 Fahrenheit. It is considered brazing when the temperature required hit above 840 Fahrenheit. Installation. International Mechanical Code 2021 Section 1305.
Fuel oil system installation. We've pulled together several regulations that address the critical points of installing a fuel oil system. Let's review them below together. Fuel oil system installation. The smallest supply line allowed is 3/8 of an inch. Only connections to the top of a fuel oil tank are allowed. The smallest return line allowed is 1/4 of an inch. Valves are not allowed on return piping. And oil levels in tanks must be monitored or maintained automatically.
Per the code, the fuel oil supply line requires a shut-off valve at entrance of the building. Fast facts. Inside or above ground tanks are permitted to have valves installed at the tank. Illustration 4M relief valve. Relief valves are required where a valve is downstream of pump capable of exceeding pressure. Illuminations of system on the discharge line of the appliance. The discharge of relief valve routes oil back to the tank. Electrical requirement for gas piping. International Fuel Gas Code 2021, Chapter 3, Section 309 and 310. The International Fuel Gas briefly mentions electrical consideration for gas piping. The NFPA 70 goes into much greater details with electrical consideration, and the SI CERT's Commercial Electrical Inspector course walk you through NFPA 70. Understanding the code, gas piping cannot be used as grounding electrode. More detail of this found in NFPA 70, but it is required to pound any metallic gas piping beside arc resistant or coated corrugated stainless steel tubing CSST. Coated regulated stainless steel tubing to ground fault current pass in the words gas piping must be grounded. This is the grounding for gas piping. Illustration 4N pounding jumper connection. As we see here, the pounding jumper must be at least 6 AWG copper wire or equivalent and no more than 75 feet long. Gas piping installation. This is International Fuel Gas Code 2021, Chapter 4. Labeling. Exposed gas piping is identified by a yellow label marked gas in black letter. The label must be at least every 5 feet, but are not required in the same room as the appliance served. Metering. The code tells us that where 2 or more meters are installed on the same premises but supply separate consumers, the piping system cannot be interconnecting on the outlet side of the meter. Illustration for all gas meters. Okay. Piping for multiple meter installation must be marked so that the piping system supplied by each meter is readily identifiable. Piping sizing, International Fuel Gas Code 2021 Section 402. How are we to size pipe or determine whether the correct size of piping has been used in an application for the pipe material? For each pipe to be sized, added up the maximum input of all appliances served by the pipe. Understanding design. Assume that the appliances could be operating at full capacity at the same time unless a diversity of load can be established. Facts. The volumetric flow rate of gas must be adjusted for altitude whereas the installation is above 2000 feet, 610 in elevation. Gas piping can be sized in a couple of ways. Section 402.4 provides equation to use into scenario. Low pressure less than 1.5 psi, high pressure more than or equal 1.5 psi. Note that the most common method to be used, table 402.4 1 through 37. Table 402.4 1 through 37. Table 402.4 1 through 37 can be used for lengths of pipe for 10 to 2000 feet for the most common pressures, diameters, gas type, and pipe material. This table will be used for all as an example in the module. Study tip. The sizing examples in the module are extensive and can be hard to follow. We provide the example in full detail so that if you care to, you can learn how gas piping is sized. You will not need to do anything as extensive as this example for the test
How to work
or
through the
to be
following
an
tables.
inspector.
You must be familiar enough with the tables to look up individual pieces of information and do some simple calculations. But sizing of a complete gas piping network will not be necessary. So, if you're looking to pass the test and be an inspector, don't feel the pressure to learn pipe sizing to the extent presented here. Instead, read through the examples and follow along with the code tables so you can see how they are generally used.
Understanding practice. Sizing table giving in manufacturer installation instruction and other engineered methods can also be used to size gas piping. To determine the correct table to use, answer the following questions, then find the appropriate table 402.4 1 through 37 to use based on our table of tables for piping sizing below. Practicing with table 1 to 37, our table of tables for pipe sizing below is a useful tool for determining which table 402.4 to use from the code after answering this question. What is the gas type? For natural gas, use table 1 to 24. For propane, use table 25 to 37. What is the pipe material? What is the inlet pressure to the pipe being sized? What is the required or allowable pressure drop in the pipe? The table of tables, pipe sizing, this shows the gas type and the pipe material that we will use and the inlet pressure and the pressure per water column and the table number of table. So they
Conversions.
call the
At this point,
table
it's
of
helpful to know
tables.
a few important conversions. Let's look at 3 conversion equations below before we continue. Be sure to look over them carefully so that you understand what is being converted.
Study tip. Important conversions. 1 psi equal 27.7 inch of water column. 1 psi equal 16 ounce. This is really ounce per square inch, but commonly referred to as just ounce. 1 psi equal 51.7 millimeter
Understanding our
HD.
conversions. Pounds per square inch is fairly easy to visualize. A pound of force spread over 1 square inch. But what is an ounce of gas? It would seem that we are talking about an amount of gas and not pressure. Really, an ounce of gas is an ounce of force per square inch, but it is commonly referred to as just ounces. What about inches of water column? When a pressure is measured in inches of water column, it is literally referring to how high the gas can push a column of water.
Define in terms. We see pressure drop in our tables. Pressure is lost as gas flow in the pipe because of the friction between the gas and the inner wall of pipe. Think about it. The amount of pressure drop allowable for piping system is the difference between the gas supply pressure and the inlet pressure requirements for the equipment served. This is illustration for P inches of water column. The gas pressure pushes the water into the tube and pressure can be measured using tape measure. Here illustration for Q, example gas piping layout. This is gas piping layout. Okay. This is a range or often. Okay, E 56,000 BTU per hour. It's pipe 1, 15 feet, pipe 2, 5, pipe 3, and here pipe 4, 5, 6, 7, 8, 9 until the meter. There we have fireplace, we have furnace, we have range, two range, the same amount of BTU per hour, and boiler 100,000 BTU per hour. Illustration for Q, example gas piping layout for piping size. Pipe sizing. This is an example of real gas system that needed to be sized. We will use the system to demonstrate the various sizing method. Find the meter and the outlet. Where gas appliance is connected, this meter is serving a number of appliances using the number of line. Sizing, this is the first method, is the longest length method. International Fuel Gas 2021 section 402.4.1. The longest length method is conservative and simple approach to fuel pipe sizing because it takes the equivalent pipe length of the longest path through the system and size all piping as if they are that length. Lengths should be determined for fittings using
the
equivalent
longest
length.
length.
See appendix.
Take a look at the example shown in illustration 4Q. We see that equivalent lengths are given for each section of piping. Sizing according to this section in the IFGC, the longest length method will be used to size all of the pipes.
Let's use illustration 4Q as an example system to see how the longest length method can be applied. Example 1. In our example, the natural gas meter provides 7-inch water column. It means 4 ounce or about 0.25 psi gas pressure. Note that this is a typical pressure for residential meter. So residential meter, we will use this 7-inch water column, 4 ounces or about 0.25 psi. Typical appliances can run with 5 to 14 inches water column. So the pipe will be used for a pressure drop 0.3 inch water column. The pipes will be scheduled 40 metallic pipes. So use International Gas Table 402.4.41. Look again and use illustration for Q along with the longest length method to size all of the pipes in the system. Think about it. The meter provided about 7 inches of water column, which is about 0.25 psi of gas pressure. The connected appliances can run with a range of pressure that goes above the 7-inch water column supply pressure, while the system could probably have more pressure drop than 0.3-inch water column. Sizing for 0.3-inch water column is the most conservative approach. Note that the only other option would to be the size system for 0.5-inch water gauge pressure drop and use table 402.42 using the longest length method, for example 1. Let's walk through the steps using the longest method and determine our pipe sizing for the system. Step 1. First, we want to determine the overall length from the meter to each of the outlet. The path to A, starting at meter, is 3 feet plus 7 feet plus 3 feet plus 10 feet, it's equal 23 feet. The path to B, again, starting at the meter, is 3 feet plus 7 feet plus 3 feet plus 30, it's equal 43. The path to C is 3-inch plus 7-inch plus 13 is equal 23. The path to D is 3 feet plus 40 feet plus 5 feet is equal 48 feet. The path to E is 3 feet plus 40 plus 15 is equal 58. This means this is the longest path is until E. Step 2. Determine the gas flow rate required at each outlet. This is done by dividing the output obtained from the appliance rated in BTU per hour by the heating of the value of the gas. This is obtained from the natural gas supplier in BTU per cubic feet. In this example, heating value of 890 BTU per cubic feet will be used. For the fireplace, it's A, we will divide this 12,500 BTU per hour per 890 BTU per cubic feet. It will equal 14 cubic feet per hour CFH. The same for furnace P, we will divide 70,000 BTU per hour by 890 BTU per cubic feet. It will give 84, and the same here for range C and D and E. From the table, use the 4 answers below with address our 4 questions near the beginning of the section entitled Practicing with Table 1 to 37. Natural gas and Schedule 40 metallic piping with less than 2 psi inlet pressure. Pressure drop is 0.3-inch water column. Which table will be used to size the pipe? It's his answer. The table is 402.41 will needed to be used to size the piping. Step 4, what is the longest length of pipe? From our calculation in step 1 for each outlet run, we can see that our longest length is 58 feet. Now find the nearest length to this is the first column of the table. What is the length will be we will use from the table, this will be 60. So the longest length is 60 feet. Think about it. For the longest length method, we have no settled on the row for 60 feet of length in this table for every calculation for every pipe. Take note of this now, because when we go to the next method, we are not confining ourselves to a single row. This is why this is the most conservative method. Okay, this is table 402.4.1, schedule 40 metallic pipe. As we see, the gas pipe is natural and less than 2 psi, 0.3 inch water column and specific gravity. Okay, as we told before, we will use 60 feet. Okay, as we see here for pipe size, this is the different sizes, and here this is the amount. Illustration as a capacity of feet for gas per hour here. Illustration for our table for 02.4.1, taking from the international fuel gas capacities of 60 feet of pipe addressing various pipe diameter are highlighted. Step 5, for each length of pipe, look up the capacity in cubic feet of gas per hour found in 60 feet row. Then find the required pipe size from the top row. Let's do this together. Pipe 1. The pipe 1 feed range with required 63 CFH. For our calculation under step 2, this fall between half and 3x4 pipe size on the table, so the pipe will be sizes 3x4. As we see here, the range is 63, so this 50, 104, this between half, the pipe size will be between half and 3x4, so we'll take the higher one, this 3x4. Illustration for us, reading the table for pipe 1, we are looking to find the right pipe diameter for 60 foot length supplying 63 cubic feet per hour. Pipe 2. Pipe 2 feed the boiler, the most demanded appliance of the meter. It requires 112 CFH, falling between 3x4 and 1. On the table, the pipe is sized 1. For pipe 3 will feed the boiler and ultimately the range too. So we need to account for both as we size the pipe, as it must take the combined amount of gas through it before split it off and first hitting the boiler. It looked like 63 CFH plus 112 CFH. It will equal 175 CFH. This is still below the 195 CFH that can be handled by a 1-inch pipe. Pipe number 4, pipe 4 feed the furnace, the second most demanded appliances on the system. It required 84 CFH and 3x4 inch pipe will be selected. Pipe number 5 serves only the small fireplace. Only 14 CFH is needed, which mean we can select half-inch pipe. Pipe number 6 will feed the fireplace but will also support the furnace. 84 plus 14 CFH, it will give us 98 CFH. We can use 3x4 pipe. Pipe 7 feed one of the range. Both ranges on the same on the system are the same. Each requires 63 CFH. Pipe 7 needed to be a 3x4 pipe. Pipe 8 supplies gas for 3 appliances ahead of it: the fireplace, the furnace, and the range. You must added all 3 appliances requirement, uh, which total 161 CFH. This must be a 1-inch pipe. Lastly, take a look at pipe 9. What do you think we must do to size? This pipe 9 feet all the appliances, so must be accounted for in this run. The total is 336 CFH, which will exceed the 195 CFH that can be handled by the 1-inch pipe. Pipe 9 will be sized 1¼ inch. Think about it. You could add pipe 3 and pipe 8 just ahead of pipe 9 to get the same total requirement of pipe 9. This works since 3 and 8 together feed the entire system with only pipe 9
The easiest and most conservative. The longest length method is the easiest, most conservative method. Notice that there were multiple safety factors added, as we sized everything on the worst case and rounded up every step.
Sizing. The branch length method, International Fuel Gas Code 2021, Section 402.4.2. Let's walk through the branch length method. First, the pipe size of each section of the longest pipe run from the point of delivery to the most remote outlet shall be determined using the longest run of piping and the load of the section. This is the same as the longest length method. Second, the pipe size of each section of branch piping not previously sized shall be determined using the length of piping from the point of delivery to the most remote outlet in each branch and the load of the section. This is like repeating the longest length method for each branch as if we were the longest method. Example 2, pulling from illustration for Q. Again, we will resize the piping using the branch length method. Let's walk through it together step by step so we understand both application points above. Step 1, lengths and flow rates to each of the outlet in the same as calculated before, and the same table 402.41 is required. Step 2, the most remote outlet is the range at E, which is served through pipes 1, 3, and 9. These 3 pipes would be sized the same as the longest length method. Pipe 1, 3 by 4 inch, pipe 3, 1 inch, pipe 9, 1 by 4 inch. Step 3, the branch lines to post P and D would use the 50 feet row in the table. Think about it. We are using the 50-foot row because the length of the pipe from the meter to post outlet we are calculating come to less than 50 feet for each. This is already one step less restrictive than the previous 60 feet we use for all pipes in the longest length method. Pipe 2 feeding D, the boiler come out to 112 CFH, which is less than 114 CFH that can be handled by 3 by 4 pipe according to the 50 feet row on the table. Using the branch method, decrease pipe 2 by 1 size. Outlet P, the furnace is served by branch pipe 4 and 6 and 4, 6 and 8. Pipe 4 is 84 CFH, still a 3 by 4 pipe. Pipe 6 is 98 CFH, still a 3 by 4 pipe. Pipe 8 is 161 CFH, still 1 inch pipe. Step 4, this leaf branch line to A and C can we and we can get to both using less than 30 feet of pipe. This puts us on the 30 feet row of our table. Pipe 5 is still well under the capacity of 12 of half inch pipe and would have no change. Pipe 7 at 63 CFH is now under the capacity of half inch pipe of 30 feet row of the table. Pipe 7 can now be reduced from
The
3
improvement
by
of the
4 to
branch
half.
length method. In this example, 2 of the 9 pipes decreased 1 pipe size. By using the more precise branch length method, pipe size decreases can result in cost savings, but it takes more time and care to size the system. The branch length method is still considered a conservative pipe sizing method.
Hybrid pressure. This International Fuel Gas Code 2021 Section 402.4.2. Systems that have multiple sections of piping with different pressure in each are hybrid pressure systems. Each pressure section should be sized independent of the other, using the longest length from the inlet to the farthest outlet, whether the outlet is an appliance or a regular. In hybrid system, each section can be sized using either the longest length method or the branch
Maximum operating
length
pressure.
method.
The maximum operating pressure for piping systems located inside buildings cannot exceed 5 pounds per square inch gauge. This is PSIG. Except under certain conditions, such as welded or brazed joints, or inside certain building types.
Define in terms. Pressures are talked about as absolute pressure or gauge pressure. Gauge pressure are the difference between the atmospheric pressure and the pipe pressure. Absolute pressure are gauge pressure plus atmospheric pressure. Understanding practice. The atmospheric pressure is 14.7 psia. The A after psi denotes atmospheric at the sea level. If we have 5 psia, this is a vacuum in comparison to the most pressures on the earth. Almost the pressure at the top of the Mount Everest, whereas 5 psig, the G after psi denotes gauge, is pressurized relative to atmospheric pressure. This is important distinction. Gas piping system installation. International Fuel Gas Code 2021 Section 404 Chapter 4 Section 404. Important notice. Take note that piping cannot be installed in or through a ducted supply, return or exhaust, or closes shunt, chimney or gas vent,
Concealed piping
carburetor
and
or
fittings
anything.
plus other regulations. Concealed piping cannot be in solid partitions, walls, or floors unless installed in a chase, casing, or a channel. Concealed fittings are limited to threaded, brazed, or welded elbows, T's, and couplings. These are regulations to keep in mind concerning a concealed installation. Also note that penetrations are not allowed to go through a foundation below grade, and plastic pipe is only allowed outdoors underground.
Drips and sloped piping. International Fuel Gas 2021 Section 408. Illustration 40 sloping gas piping. If the gas isn't dry, the piping must be sloped at least 1 by 4 inches in 15 feet to prevent traps. A drip must be installed at any point in the line of the pipe where condensate could collect. Illustration for you installing the drip. as a trap. At the outlet of the meter, a drip should be installed as a trap so that collected condensate will shut off the flow of gas before it runs back into the meter. Drips require ready access to permit cleaning or emptying. Think about it, a drip cannot be located where the condensate is subject to freezing. Sediment Trap, International Fuel Gas 2021, Section 408.4. Sediment Trap as shown in Figure 408.4 in your FG. This is the sediment trap. Is required downstream of the appliance, shut off a valve and closed to the inlet of the appliance. Illustration 4V Figure 408.4 T-fitting sediment trap. Sediment trap keep small debris from clogging gas valves and nozzles. Fast facts, sediment trap are not required for illuminating appliances, ranges, clothes, dryers, decorative vented appliances, gas fireplaces, and outdoor grills. Other important notes for the international fuel gas piping. Let's look at some important requirements specified in the code regarding gas piping as we close out the fuel supply module. Read through the graphic below as we highlight this and note the section they come from. Study them. Important gas piping items from the international gas: mechanical and corrosion protection for O4. This section details requirement for shield plates, conduit, dielectric fittings, and pipe coating. Inspection, testing, and purging for O6. This section lists the requirement for visual inspection, pressure test with leak detection, and procedures of purging procedure of purging the pipe cleaning the pipe. Shut off valve 409 must be accessible. Shut off valve must be accessible. Yeah, this must be located at every meter building, tenant, regulator, and appliances. Flow control for 110. This section addresses pressure regulated from appliances need a lower pressure than system pressure. This must be accessible and if vented to the outdoor. Section 412 and 413 include regulation about motor vehicle using liquefied petroleum and natural gas. Piping support 415. This section explains that support intervals cannot exceed the spacing specified in table 415.1. Support of piping: steel pipe, okay, and this is the spacing for support. For example, for half inch we will support every 6 feet. For 3 by 4 or 1 we will support every 8 feet, and so on. Illustration for W table 415.1 piping support taken from international gas. This table details the required spacing support for piping based on piping diameter and pipe material. Offer pressure protection. International Fuel Gas Code 2021, Section 416. Study tip. Offer pressure protection is discussed in the section and required when a gas supply is greater than 2 psi and appliances are 14-inch WC or less. Water column, inch water column. When offer pressure protection is necessary, on the following is required: 1. Pressure relief valve. 2. Monitoring regulator. 3. Series regulator installed upstream for the line regulator and set to continuously limit to pressure on the inlet of the line regulator to the maximum value specified in section 416.2.1. Number 4, an automatic shut-off of device installed in series with the line pressure regulator and set the shut-off when the pressure on the downstream piping system reaches the maximum value specified by section 416.2.1. The device shall be designed so that it will remain closed until manually reset. Let's take quiz. Okay, what is the capacity of 50-foot length of 2-inch Schedule 40 steel pipe sizes for 0.inch water gauge pressure drop with the inlet pressure drop of 1 psi? It requires a capacity of 50 foot. Okay, let's flag this one. In the direction of the gas flow, in what order is it permitted to install the following devices? In the direction of gas flow: shut-off valve, sediment trap, union, appliance inlet. Okay, this one. Where gas is supplied at a pressure higher than dot, serving appliances that operated at gas pressure of dot or less, offer pressure protecting device are required. When the pressure is higher than 2 psi and 14-inch water gauge. A gas piping system with a total volume of 2,000 cubic feet in paying pressure testing. What is the minimum test duration? Gas piping system with a total volume of 2,000 feet. We know that half hour for 1,000, this means 1 hour. A high octane gasoline with a closed up flash point of 40 Fahrenheit and the boiling point 250 is classified as class 1I flammable liquid, class PI, class 1C, octane gasoline. It's liquid. Okay, I don't know. See the result and we'll correct anything. We'll submit with the flagged ones that we don't know. Okay, back to quiz. Let's check the correct answer. What is the capacity of 50-foot length, a 2-inch Schedule 40 steel pipe sized 0.5 water column pressure drop with the inlet pressure of 1 psi? The correct answer is 168. This is in section. Let's go to the next. In the direction of gas flow, we answer this correctly. In the order is permitted is shut-off valve, sediment trap, union, and appliance inlet. And we correct this. We also answer this correctly. Where is the gas is applied at pressure is higher than 2 and serving 14 or less, we need offer pressure. A gas piping system with a total of volume 2,000. Because we need to, because it is 1 hour per 1,000 minimum gas piping with a total volume of. Okay, let's see this section. Okay, we will revise it. Next, a high octane gasoline. Okay, this is in chapter 2 in definition. So we now studied the fuel supply. Okay, we studied what is the fuel supply and general regulation for it. We studied also the selection of piping and the high pressure and types of piping. Uh, this all about the fuel supply section.